Have you ever stopped to think about how the world's most critical computers, the ones running our banks, our airlines, our governments, actually store their data? Well, today we're going to pull back that curtain. We're diving into the mainframe to understand the incredibly powerful and time-tested system it uses for data storage. Let's get right into it. Okay, so here's our game plan. We're going to start with the absolute basics. What in the world is a data set? Then we'll check out a couple of simple types before we meet the real star of the show, VSAM. We'll break down its 4 different flavors, see how it's actually managed, and then we'll zoom out to see how it all fits together. All right, let's start at square one. Before we can get into all the high-speed, complex stuff, we have to understand the fundamental building block for all data on a ZOS mainframe. It really all comes down to this one question. See, on your laptop, you think in files and folders, but the mainframe, which has been handling massive amounts of data for decades, it has its own language, its own vocabulary, and it's incredibly precise. And the most important word in that vocabulary is the data set. Honestly, the easiest way to think about it is that it's just the ZOS version of a file. Inside a data set, you have records. You can picture each one like a single row in a spreadsheet. And each record is made up of related fields, like an employee's name, their ID, and their department. It's a simple concept, but it's the foundation for literally everything else. So now that we know what a dataset is, let's look at the 2 most basic models you'll find in the mainframe toolkit. These are the reliable workhorses that get used for all sorts of essential jobs. First up, you've got sequential datasets. And that cassette tape analogy? It's perfect. To find anything, you have to read the records one by one, right from the beginning to the end. It's great for things like log files or generating big reports. Then you have partitioned datasets, or a PDS. This is completely different. It's more like a filing cabinet. It has its own little directory inside that points to individual members, which are like the folders in the cabinet. This lets you jump directly to the one you need, which makes it perfect for organizing things like program source code. But here's where we hit a wall. Reading data like it's on a cassette tape is fine for some things, but it's a total non-starter when you're trying to process millions of transactions a second. That limitation created a huge problem that needed a much, much smarter solution. I mean, seriously, think about it. How do you do that? If your bank's ATM had to read a file from the very beginning every time you wanted to check your balance, you'd be standing there for hours. Obviously, there has to be a way to jump directly to the one specific piece of information you need right now. And that's where this powerhouse comes in. For the kind of speed, efficiency, and complex data wrangling that modern applications demand, the mainframe world turns to one thing: VSAM. Now, the most important thing to get here is that VSAM isn't just another file type. It's a whole access method. You should think of it as a complete system, a high-performance engine that's built from the ground up to define, store, and retrieve data with incredible speed. This is the magic that makes indexed and direct access possible. So how does it pull off this speed? Well, it's all about smart organization. Data gets stored in chunks called control intervals. Just picture a page in a book. Each page holds a few records plus some empty space for new ones you might add later. Then, a group of these pages forms a chapter, which is called a control area. This 2-level structure is VSAM's secret sauce for managing space and finding records without the application having to worry about any of the messy physical details. But, of course, VSAM isn't a one-size-fits-all kind of thing. It actually comes in 4 main flavors, and each one is designed for a very specific kind of job. So let's take a closer look at each of them. First, and by far the most common, is KSDS, which stands for Key Sequenced Dataset. This is the classic. Every single record has a unique key, like a customer ID or an order number. And that's the core power of VSAM right there. You use that key to go directly to a record without searching. The analogy of an index at the back of a book is absolutely perfect. You don't read the whole book, right? You look up the topic in the index and jump straight to the correct page. That's KSDS. Next up, we've got ESDS for entry sequenced. This one's super simple. Records get stored in the exact order they're added, and new data always gets tacked on to the very end. This makes it the perfect setup for things like audit trails or transaction logs, where the chronological order is everything. It's just like writing in a diary or a ship's log. You never go back and squeeze an entry into the middle. Then there's RRDS, the relative record data set. This one is all about position. It's like a big set of pre-numbered slots. You get to your data by telling it the slot number. Hey, give me the record in slot 54, or put this new data into slot 102. The numbered parking space analogy is a great way to think about it. You go directly to a specific numbered spot. And finally, we have the oddball of the group, the LDS, or linear data set. This one is different because it has no structure at all, no records, it's just a raw stream of bytes. Think of it as a big, blank canvas that VSAM provides to other really powerful programs, like the DB2 database, so they can manage their own data in their own special format. You would almost never use this directly in an application program. Okay, so we've seen the what, the different types of VSAM. But what about the how? How does a developer actually go from just an idea to a working data structure on the system? Well, the workflow is actually pretty logical. It's really just three main steps. First, you define the structure of the dataset. What type is it? How big is it? What are its keys? Next, you load it. Populate it with all of its starting data. And finally, once it's defined and loaded, it's ready to use in your application, where programs can read, update, and add new records. And here's the key, you're not building this stuff by hand. The tool for the job is a really powerful utility called IDCMS. You give it a set of commands, like define cluster, and those commands act as a blueprint, telling IDCMS exactly what kind of VSAM dataset to build. It is the master tool for managing the whole VSAM environment. All right, we have gone through a lot of technical details here. Let's take a second, zoom out, and really look at the big picture so we can see how all these pieces fit together. This summary table really lays it all out, doesn't it? You can see that clear progression. You start with the simple, one thing at a time access of a sequential dataset, and you move all the way up to the super flexible, key-based power of a KSDS. Every single one of these types has a specific job it's good at, whether that's storing code in a PDS or driving a high-performance database with a KSDS. So if you walk away remembering only 3 things today, let it be these. Number 1, a dataset is just the mainframe's word for a file. Number 2, VSAM is that high-performance engine, that access method, that makes modern, complex applications possible. And number 3, IDCAMS is the command line tool you use to build and manage the whole shebang. Now, when you stop and realize that the core ideas behind VSAM have been battle-tested and proven for over 5 decades, it leads you to this one final, really fascinating question. Why? Why does this system, designed so long ago, continue to be the absolute bedrock for the world's most critical financial transactions? The answer is actually pretty simple. It has unparalleled reliability, incredible speed, and just ruthless efficiency. Thanks for watching.